Hello everyone. In this particular video, we are going to solve the problem number 1.53 from Irodov, and that is related to kinematics. So let us first understand the problem and then we will solve the problem step by step. A ball of radius r is equal to 10 centimeter rolls without slipping down an inclined plane so that its center moves with constant acceleration of w is equal to 2.5 centimeter per second square. So basically a ball is rolling on this inclined plane with the acceleration of w is equal to 2.5 centimeter per second square, but it is just made like this, and it is saying that we are having the acceleration of w is equal to 2.5 centimeter per second square in this direction. Okay, now it is saying that the ball is having the rolling motion without slipping. So basically if we talk about the velocity at the bottommost point, as the ball is moving in this particular direction with the velocity of v, so it will have the velocity in this particular direction, and as it is rotating with the angular velocity of omega, it will have the velocity of omega into r in this direction. And it is rolling without slipping, meaning is that this particular point O, which is touching with the surface, it is having the zero velocity momentarily. So basically v minus omega r is equal to 0. So v is equal to omega r. This is the condition of rolling without slipping. Radius of the ball is given as, that is, r is equal to 10 centimeter. Okay, and it is asking to find the velocity at several points after t is equal to 2 seconds. Okay, so let us talk about a point. So in the a part, the ball is having the acceleration of a is equal to 2.5 centimeter per second square, and a point is the topmost point, b is here, and this is point O. So let us first talk about point O. Point O. At point O, we are having the velocity in this particular direction and omega r in this particular direction, and both are equal. So we can write the resultant velocity is equal to v minus omega r, and both are equal, so that is equal to 0. If we talk about point B, let us take point A. At point A, we are having the velocity of v in this particular direction due to translational motion of the ball, and omega r in this same direction due to the rotational motion of this ball. And here in this case, velocity is equal to omega r, so we can write 2v is the resultant velocity of point A. So we are having the resultant velocity of 2v. Now let us find out the velocity v. So acceleration is given as 2.5 centimeter per second square. So we can write v is equal to initial velocity plus acceleration into time. Initial velocity is equal to 0. So velocity we can write it as 2.5 into t. And at t is equal to 2 seconds, we are having the velocity of 2.5 into 2, that is 5 centimeter per second. So this is the velocity of the ball at the time instant of 2 seconds. So let us substitute the value here. So we will get 2 into 5 centimeter per second, that is equal to 10 centimeter per second. So this is the resultant velocity. Now let us talk about at point B. At point B, we are having the velocity in this particular direction due to the translational motion, and due to the rotation motion, we are having the velocity that is equal to omega r, and omega r is equal to v. And we can see here both the velocity vectors are mutually perpendicular to each other. So we can write the resultant velocity is equal to v square plus v square under root, that is equal to root 2 times v is equal to 5 root 2 centimeter per second. Okay, so this is the velocity at several points we got. Now let us talk about the acceleration. First of all, let us draw the ball again. So this is the ball, and here we are having point O, point A and point B. First of all, let us talk about at point A, at point O. Okay, here at point O we are having the velocity in this direction and omega are in this particular direction. Okay, so in the tangential direction we are having the net resultant velocity in the tangential direction is equal to 0 because velocity is equal to omega r. So we are having two component of acceleration. First is the at, that is tangential acceleration in the tangential direction, and AC, that is the centripetal acceleration or the normal acceleration towards the center of the wheel. Okay, so here as the resultant velocity in the tangential direction is equal to 0, if we write the tangential acceleration, that is equal to d by dt of velocity of resultant t, that is equal to 0 because velocity resultant in the tangential direction is 0. If we talk about AC, that is the centripetal acceleration we know that is equal to omega square r, and in this particular case velocity is given as omega r, so we can write it as v square by r. Okay, v is given as at t is equal to 2 seconds, we have found out that is 5 centimeter per second. So if we substitute here, we will get 5 square whole divided by r is 10 centimeter, so we will get 2.5 centimeter per second square. Okay, so if we talk about the resultant velocity, that is nothing but the centripetal acceleration, that is equal to 2.5 centimeter per second square. Now let us talk about at point A. At point A we are having the resultant velocity in this direction, and that is equal to resultant velocity is equal to 2 times v, and at any particular time instant we have found out v as 2.5 into t, so we can write 5 into t. So this is the resultant velocity we got in the tangential direction. And if we talk about the centripetal acceleration, so that will be in this particular direction, and the tangential acceleration will be in this particular direction. So at point A, if we write at, that we can write it as d by dt of velocity resultant in the tangential direction, that is equal to d by dt of 5 into t, that is equal to 5 centimeter per second square. And if we talk about the centripetal acceleration, that is equal to omega square r, or as v is equal to omega r, so we can write here v square by r, that is equal to v we have found out 5 whole square by 10, that is equal to 2.5 centimeter per second square. So if we write the resultant velocity, that we can write it as at square plus ac square under root, because both the acceleration are mutually perpendicular. So we can get 5 square plus 2.5 square under root, that is equal to 5.6 centimeter per second square. Now let us talk about at point B. At point B, if we see here, we are having the velocity in this particular direction due to the translational motion, that is equal to 2.5 into t, and we are having the velocity in this particular direction, that is equal to omega r, and that is also equal to 2.5 into t. First, if we talk about the tangential acceleration, then tangential acceleration we can write it as at is equal to d by dt of velocity in the tangential direction. What is the velocity in the tangential direction? That is equal to omega r, and that is given as 2.5 into t. So if we differentiate, we will get d by dt of 2.5 into t, that is equal to 2.5 centimeter per second square. Okay, and now if we talk about the centripetal acceleration, then we are having the acceleration centripetal due to the rotation, that is equal to omega square into r, and as we have the velocity in this direction, so we will have the acceleration in this direction due to this particular velocity. So we can write acceleration AC1, that is equal to dv upon dt is equal to 2.5 centimeter per second square okay. And in towards the center, let us say we are having AC2, okay. So the resultant velocity, AC resultant, we can write it as AC1 minus AC2. What is AC1? That we have found out here, that is 2.5 centimeter per second square. So 2.5 minus, because both are in the opposite direction, and what is AC2? That is V square by R, and that we can write it as 2.5 minus 2.5, because this V square by R is same everywhere, so that is equal to 0 centimeter per second square. So basically at point B, centripetal acceleration, resultant centripetal acceleration is 0, and the tangential acceleration is 2.5 centimeter per second square. So the resultant acceleration we can write it as 2.5 centimeter per second square. Okay, so I hope the entire procedure is clear. We have found out the velocity at several points and the acceleration at the several points. Thank you.